Okay, this lesson will be about the first step in our force procedures that you will be using for any force problem. Right. Okay, so we have a problem here on the screen. I have simply drew a picture here. You guys have, most of you are probably driving. Some of you are still aspiring to driving. Um, but the real question here is, what is this problem about? Okay, we have a tow truck, we have a car. The car is being towed by the tow truck. So what is the problem about? Probably the car. Keep in mind that just about everything that we're going to be doing is going to have some sort of picture associated. It did with kinematics when we solved kinematics problems. There was always picture based. Okay. Oftentimes you'll be given a picture. Other times you'll be given a whole bunch of words, and you have to turn those words that turn that paragraph into a picture, turn it into a story. And then the problem becomes turning that story into a physics solution. Okay, so the problem here is going to be about the car. Okay, the first step is to draw the free body diagram. Now, physicists tend to be a lazy bunch, so we don't write free body diagram all the time. We write FBD. Okay, so we want to figure out how to draw the free body diagram. Now, the free body diagram is that I'm going to be giving you is going to be a little bit different than what the AP is going to have you do. But any free body diagram is going to be basically this. You're going to have a mass inside a box. Now, the AP is not going to have a box. They're just going to give you a dot. Okay, and let me show you what the AP is going to expect from you, and then you can compare that to what I will show you for the free body diagram that I'm going to be expecting from you all. Okay, for the AP would probably give you for the car, they would say draw the free body diagram for the car, and what the AP will give you is that would be the ground, and they'll give you a dot here, and they'll say draw the free body diagram for the car. Okay, now instead of the mass in a box, they give you a dot. And now to that, you will then attach the forces that are acting. What forces are acting here? You could probably name them. Okay, the forces that are acting will be obviously the ground pushing up. You have gravity pulling down. There's going to be friction to the left. There's going to be the tow truck, which is pulling at some angle. If you notice, it's not pulling, it's pulling it to the right. It's also pulling up. The front of the car is up, remember. Okay, so we're going to have different forces that are acting, and you will just simply have one force there, one force there, one force there, and one force there. This would be friction. This would be the normal force. This would be the force of gravity, and this would be the tension. Okay, this is what the AP would expect you to have. Instead of having a dot, I will say draw a mass, draw a box, and you're going to put the mass inside the box. There is a reason for that. If you simply have a single mass, it doesn't matter if you have a dot or a box. But if you have more than one mass, you're going to have more than one free body diagram. Remember, the free body diagram is going to be applied to each and every mass that you see in the problem. So if you have more than one mass, you're going to have to be able to somehow identify the mass that goes with that particular free body diagram. All right, and once you draw the free body diagram, everything is there. Once we draw the free body diagram, all the information that you have about the problem is there on that diagram. We don't have to refer back to the problem and go searching in the text for what that mass is. It's in the box. We know exactly where it is. Okay, so let me get rid of my drawing and go back to what I'm expecting you guys to do for our class. Okay, so mass inside a box attached to force vectors, like I had in the like I just erased. Force vectors are going to have a name, first of all. I put the names up there. I erased them, but I had a name there. Make the name informative. It's going to have a direction. The arrow is showing the direction, the formula, if appropriate, and the values, if any. Okay. Oops, let me get control of my screen again. That means I have to push that button and push that button, and there it is. Yay. All right, so there's my free body diagram that I'm expecting. Okay. T is the names of the forces that the names are up to you. You can call them whatever you want, but make them descriptive. We have the tension in the rope that's pulling up. I put the angle in there. The angle is not usually on a free body diagram. I just put it there to help the discussion along. We have the normal force acting up. we have friction acting to the left, and we have the weight, the force of gravity acting down. Okay, now the I say here to put in the formula if appropriate. There is no formula for tension. The normal force, there is no formula for normal force. It's going to be different for each problem, and it usually comes. We'll see. It usually comes from the problem that we're dealing with. The force of friction oftentimes does have a formula. It's related to what the normal force is. We don't need to have that now. Let's just pretend we don't know what the force of friction is. We'll just put F for the force of friction. The weight is going to be equal to m times g. Okay. As I'm making this video, I may or may not have defined the weight for you by this time, but generally it's going to be m times g. That happens so often, I will even leave off the w. I would just use mg's, both the name and the formula. Okay, g is 9.8 or 10. You can just leave it for g and then ultimately put in 10 when you solve it. So if you know the values, if you knew the tension was 100 newtons, you would put 100 newtons there, or just leave it as T. Now I'm not putting in any I'm not putting in any numbers here for the procedures lessons that we're going through. I know that sort of is going to bother you, but I'm going to go through the procedures in a very general way. Immediately after, we'll start doing some problems and putting numbers in. That'll make you feel much more comfortable. Okay, so again, the bottom line is draw the free body diagram. We have, let me get my little spotlight here again. We draw the free body diagram free body diagram, I'm jumping ahead there. Free body diagram is the mass inside the box, 2,000 kilograms, whatever it happens to be, and to that box you apply the forces as given.